Welcome, everybody. We're going to give everyone just another minute or two to join, and then we'll get started with today's presentation. All right, we'll go ahead and get started. Wanted to welcome everybody on behalf of Fortified Data. My name is Andrea Kircher, and I'm the Director of People and Strategy. We're really excited for today's expert series session because we have a guest from Pinnacle Solutions Group, as well as Frank Gill from Fortified Data, who many of you guys have grown to know and love. So we're going to go ahead and dive into our session today with a brief introduction from Frank Gill, Senior Consultant at Fortified Data, followed by Jeff Cook, Data Engineer at Pinnacle Solutions.
All right. Yep. My name is Frank Gill. Just says on the slide, I've been doing this for more than 22 years. Been working with SQL Server since 2007, and over the past 10, 12 years, my focus has been on kind of migrations, upgrades, and a lot of work in Azure. So with that, I will turn it over to Jeff for an introduction.
Yeah, hello, my name's Jeff Cook. I'm a data engineer at Pinnacle Solutions. Been working in the data arena for a while. Started with dimensional modeling, relational databases, and Oracle Exadata, and kind of migrated to Hadoop and Python and Spark, and probably for the last 5, 6 years been developing in cloud, either Azure Databricks, AWS, Python, and Spark. So kind of migrated through those technologies over time.
Wonderful. Well, welcome, Frank and Jeff. We're excited to have both of you this afternoon. From our audience, we'd love for this to be an interactive session. So if you do have questions at any time throughout the presentation, feel free to drop them in either the chat or the question and answer, and I'll be sure to get those to Frank and Jeff so they can provide some feedback on those. So with no further ado, I think we'll jump in.
All right. So what we're going to cover is recommendations for modernizing a legacy environment, and specifically around questions that we think you should ask when you are looking to modernize a legacy environment, be it an in-place upgrade, be it a migration, be it kind of a redesign. There are kind of different ways you can go at this. So we're going to go through some questions that you need to ask. And we are going to be covering this topic from two different perspectives. I'm going to be talking about it from the perspective of migrating and upgrading a SQL Server database environment. And then Jeff's going to be talking about it from the perspective of modernizing a database environment using a data lake, using some of the tools that he mentioned in his bio. So I just wanted to get that out there at the start. And with that, we will dive in. So I said that we're going to talk through some questions to ask, and they're fairly simple questions on the face, but as you dive into them, they get more complex. And those questions are, why are you modernizing? This is one that I think gets missed some of the time. People just want to move to the new shiny thing, and they don't really give enough thought to why they are doing it, because that will drive a lot of these other questions. What is the inventory of things that you are looking to upgrade or migrate? Where is it going to go? What makes sense? And this is, I think, where that split between the two of us is going to happen, because I'm going to talk about where from a SQL Server cloud-based perspective, and Jeff will be talking about it from the data lake perspective. What mechanism are you going to use to get the upgrade done or the migration done? And then finally, when, this idea of scheduling a migration upgrade, making sure that all the pieces are in place and everybody is on the same page. So we'll jump into these questions in more detail. So from the why perspective, there are a couple of different reasons that you might want to might want to upgrade or migrate. One of those is modernization. So in terms of legacy systems, as SQL Server evolves, as other technologies evolve, there are additional features that are added. Things will run better, things will run faster. And then from a security perspective, if you are running older versions of SQL Server, Windows, any sort of software, you are potentially opening security holes that people can exploit. And security is a big thing these days. Ransomware, that kind of thing it's really important to modernize. Cost savings. So if you're running in an on-prem environment, if you're running in a data center, if you're running in a hosting provider, you may not be taking full advantage of the resources that you have available to you. So one of the things that a migration upgrade can give you is the ability to right size your environment. Figure out how big do the servers that you're going to run on, how big do the resources you're going to run on have to be to allow your systems to run while minimizing the amount of money you're spending on those resources. Additionally, you may have the opportunity to consolidate applications, consolidate uh, applications onto the same resources. And then finally, one of the big wins for moving to managed services in the cloud is it reduces the administration that you need to do on the infrastructure side. I will talk through two of those options with SQL Server. And as I said, one of the big wins is that you don't have to worry about patching the OS. You don't have to worry about administering storage. Sort of anything that sits under the database layer is managed in these environments. Talked about modernization, just showing some end of support dates for both Windows and SQL Server. You can see that Windows Server 2016 goes end of extended support January of 2027. SQL Server 2016 goes end of extended support in July of next year. And basically, what that means is extended support says you are paying Microsoft additional money so that they will give you security patches for these products. The end of mainstream support means that those security patches are not going out to the general public. So, from that perspective, 2022, Windows Server 2022 goes end of mainstream support in October of next year. And then actually, wow, 2019 went end of mainstream support last 2 weeks ago. I did not read that when I posted this. So these are things that you need to keep in mind in terms of the software that you're running. And these are big reasons that you want to make that migration / upgrade to secure your environment. Cost savings, I kind of talked through these already. Opportunities for right sizing and opportunities for consolidation. Just understanding your workload, understanding how much horsepower do you need to run your systems, and then building out your systems to provide that horsepower and not overspend. And then finally, reducing administration.
Frank, before you jump into that, sorry
Sure.
that one just popped
No
into
problem.
the chat with
Mhm.
SQL 2019. Is it January 24 or January of 25?
2019. The end of mainstream support is February of this year, so it actually just passed.
Okay, thank you.
All right. And then finally, reducing administration. I talked about cloud-based managed solutions handling that infrastructure administration. And the upshot of that is that by taking that workload off your plate, it can free up resources to do things like business development and make your applications run better, faster, stronger, just without having to worry about that admin overhead. Any other questions?
Nope, not yet.
Then, Jeff, I'll throw over to you, kind of talk through the why here from your perspective.
Yeah, let me talk through the why of migrating to a data lake. Some similar concepts, of course, because Frank was talking about moving to the cloud. I'm talking about the same thing. But there's a lot that can come, as he's pointed out, from modernization as far as getting off the on-prem things, support. I'll dig into cost savings in a little more detail now And I got some things I'll come back to later around that about ways that you can reduce costs, not just from having a physical server, but also have efficiencies in the cloud. And then the timelines is really a big thing too. I'm not waiting to procure a machine per se. I could spin up a machine, a virtual machine, in a few minutes, and maybe I need a larger machine. I could do that again in a few minutes. So hopefully, I've taken what could be weeks or so down to hours or minutes or so. Can you go to the next slide, please, Frank?
Sure.
So similar to what Frank was saying, there's some things in the cloud. I'm going to talk a little bit about Databricks because I have a lot of familiarity in that area, but any of these cloud environments are going to have some end of support dates for things that they support. Databricks has the same kind of thing. They're releasing different runtime versions that sit over the cloud of your choice, over Amazon AWS, Microsoft Azure, or Google GCP. And that, they've got certain dates where that's going to run out of support, and you're going to have a hard time upgrading or getting packages for it or getting support if you have a problem. And then Amazon has a Linux that's widely used through EMR clusters and other things out in Amazon, and they have dates where that's going to expire as well. So just as Frank pointed out, we still have some of those issues in a data lake that is not going to go away. You need to manage it. Maybe it's a little bit easier because you don't have, like I said, physical servers, and you can just do some testing by spinning up a new instance and trying your software against a later version to see if it's going to work, or you're going to have to do any other package or application upgrades. But we've still got some versioning issues there we have to deal with when we go to a data lake. Can you go to the next slide, please? So cost savings, estimating cost savings is a challenge, I feel, in the environment. If you all the cloud, the major big three cloud vendors that I just mentioned have pricing estimators. But when you go through these estimators, sometimes it's hard to tell, okay, what am I just taking this machine I have now that has 32 gig of RAM and a terabyte of storage and X number of CPU, and I push that over? Or maybe I'm not using that whole machine, or maybe I need more. Maybe I want to share some resources in the environment. And then going through those pricing estimators is actually pretty challenging. I mean, if you log into Amazon AWS, it's got over 200 services, and those have sub pages under those. It's really complex. So in this regard, I would say get a good handle on what you're doing now, not just the size of the machines, but what resources are they using and stuff, and try to size that in the cloud. You're still going to have an iterative process I'll talk about a little bit to monitor that and to tweak it. But that might get you a starting point as you dig into trying to say, what's it going to cost as I go into the cloud? What is it going to take this application over to the cloud? Next slide, please. And then the timelines, as I mentioned, it's easy to spin up a resource. It's easy to spin up resources of different types. As I mentioned about versions, I can try a different version of runtimes. I can try different packages. All this is pretty quick in the cloud, so it gives me an opportunity to spin up development environments pretty fast. If I need more resources, I can get a larger machine. Maybe I can scale up in a cluster and get a higher number of machines that I can scale to when my workload increases. And along with this, gives me a chance to fail fast. If I'm having a significant resource issue, if I'm having an access issue or something else like that, I can identify these things quickly and hopefully address them and remediate them quickly, and not have to worry about getting new equipment or bringing in other experts, teams, admins that I may not have easy access to identify and address problems as I go through my delivery cycle. Okay, next slide, Frank. I think this is you too.
Yep. Yeah, so the next question you want to ask is what? What are you going to move? And two of the things that sort of come together here are both an application inventory, understanding what applications are moving, and then what is sitting underneath those applications. What resources do you need to upgrade or migrate? And that can be challenging because, I've been in organizations where you are looking to move an environment and you run into cases where you don't know the applications, all of the applications that are touching that environment, and people get very angry if their environment moves and they don't know about it. And that gets into the idea of organizational alignment. You want to make sure that all of those owners, all of the people who have ownership of applications that are touching the environments that you are working with are aligned with that migration. That alignment, it can be voluntary, it can be involuntary. You could have cases where you just need to tell somebody, look, your application, the resources that support your application are going to move on this date, and you need to be prepared. And there can be some tough conversations around that. There can also be some tough conversations around priority. I had one migration where there were, let's say, 10 applications in play, and everybody thought they were the priority one application. And you need to kind of be able to talk people down from that priority one level, just to make sure that they understand where they kind of fit in the pecking order. So that, and once again, I've kind of talked ahead on these slides, knowing what resources support each application, knowing who's using those applications. And then something else here is if there are test environments in scope, this can be a way to run a test of this upgrade process. Working on a migration currently where they have dev, UAT, and prod, and UAT basically mirrors prod in the new environment. So that is what they are using to do all of their application testing. We can work out all the bugs or anything that any challenges they're going to run into in that UAT environment. And it's going to make the production effort run more smoothly. And then also that organizational alignment, leveraging the product owners to foster organizational alignment. This is something that Jeff brought up, just the idea of having a resource that can communicate. I'm a technical person. I'm pretty good at communicating, but if I have someone who knows those application owners and has those relationships already, that will make that process run much more smoothly. Making sure those app owners are on board, and then also setting due dates for that application buy-in. Just doing everything you can to get those application owners on board, but setting those deadlines to say, look, you need to figure out how this is going to go by X date, because that will allow us to make the dates that we have for our upgrade/migration. Then I'm going to speak to where from my perspective, and the three wheres that I've got are managed solutions in the cloud, SQL Server on virtual machines in the cloud, and then SQL Server running on VMs on-prem. And from the managed solution perspective, I've already stated that kind of one of the big wins here is the removal of that infrastructure admin. With managed solutions, you also have the ability to scale these things. If you stand up a managed solution and it is not giving you the horsepower you need, you can scale it up. If you find that you have resources that you're not using, you can scale that back down, and that can help with that cost management. SQL Server on a VM, you can run SQL Server on a VM in the cloud, and there you're effectively using the cloud as your hosting provider. So I stand up SQL Server on a VM in Azure. I am responsible for managing my storage, my OS patching, all of that. And then SQL Server on a VM on-prem. This is a tried and true solution. It is something that you can do if you have issues or questions about moving to the cloud. It does give you that bonus of virtualization so that you can potentially use resources as optimally as possible. So from the managed solution perspective, I'm going to talk about two different options, and these are both in Azure. First one is Azure SQL Database, and the second one is Azure SQL Managed Instance. From the Azure SQL Database side, this is a single database. So if you're used to running an instance of SQL Server, on an instance of SQL Server, you can run multiple databases. Those databases can talk to one another, and you can potentially talk to another instance of SQL Server. With Azure SQL Database, it is a single database, and you can have cross database and cross server communication, but it is challenging. It's not as easy as it is in an instance of SQL Server. For that reason and some others, one being that there's no SQL Server agent. So if you're using SQL Server agent jobs to manage business processes, the agent doesn't exist with Azure SQL Database. And those two things and a number of others mean that this is not an ideal destination for a full migration. If you want to take an instance of SQL Server and migrate it, Azure SQL Database may not be for you. This is ideal for new development. So if you are kind of pivoting to something like a multi-tenant system, or changing the way your applications work, Azure SQL Database can be really good for new development. Couple of the bonuses here is that high availability is built in, that underlying infrastructure is managed, storage is managed, database backups are managed. These are all things that you don't have to worry about. Azure takes care of them. And just to show you what this looks like. So on the previous slide, I mentioned service tiers. So there are two different service tiers here. There's general purpose and business critical. And from a high availability perspective, the big difference between the two is that with general purpose, you are basically getting HADR using storage redundancy. So you have your compute nodes running, and in the event that your primary replica here on the left-hand side of this slide, if that goes down, it will basically spin up a new compute node to run your SQL Server, and it will point at the storage that is being used for your data and log files. So that failover time is kind of slower than business critical, but for a lot of applications, and I would say most applications, the downtime, we're talking sub-second to second. So it's not a huge amount of downtime, but it's going to be more downtime than business critical. With business critical, it's effectively standing up an always-on availability group. So you have a primary replica and you have 3 secondary replicas. And if there is an issue with the primary, it will fail over. And that is kind of a sub-second, possibly millisecond failover time. And if you have retry logic in your application, it's going to be transparent to you. And the other thing here is that your data and log file are stored on SSD, where with the general purpose, it's being stored on Azure Premium Storage. So Andrea, any questions there?
I don't see any at this time.
Okay. So the second managed solution I'll talk about is Azure SQL Managed Instance. And it looks and feels like an instance of SQL Server. So you can migrate mature applications there. If you have an instance of SQL Server that's running a group of databases for an application or group of applications, you can move those to managed instance. Once again, you have service tiers, and there's scalability here. That high availability is built in. And then once again, all of that underlying infrastructure is managed. And then the other plus with managed instance is that SQL Server agent does exist. So in that case where I'm running an instance of SQL Server and I want to move that to the cloud, I can move that to the managed instance and have all of those agent jobs there, managing my business logic, doing what they do. So I will flip to this slide, and it may look familiar because it effectively works the same way. On the general purpose side, you do have the premium storage hosting your data and log files, and you do have that idea of storage redundancy where the new replica If the primary replica fails, the new replica will just point at those files. On the business critical side, I've got that concept of the availability group failover, where it is pushing those log records between those replicas, the secondary replicas. And so you're guaranteed that you are going to be synchronized between those replicas. So the failover can happen very quickly. So that is managed instance. SQL Server on VMs in the cloud. As I said before, this is leveraging the cloud as your hosting provider. It looks like a normal virtual environment. You're standing up virtual machines. You can scale these virtual machines up and down, but that admin on the infrastructure side is required from the OS level. If you want high availability and disaster recovery, you need to build this out. They have done some things to make that build out simpler. You can actually run through effectively a wizard in Azure, and it will build out what you need from a clustering perspective, everything that you need to sit underneath that availability group configuration. And then once again, you've got to manage storage. And the last one is SQL Server VMs on-prem. This is for the cloud averse. If you don't want to move to the cloud, if you have security concerns, if you have concerns about performance, just about not being able to control what you are doing, you can stand up VMs on-prem. I'd say over the past 10, 12 years, I've seen that percentage of people in this category has diminished. It used to be there were a lot of people who just wouldn't run on the cloud. And there are things you can do to kind of mitigate some of those challenges. Private clouds, that kind of thing, to give yourself more control of that cloud environment. But SQL Server VMs on-prem are still a viable option if you have the hardware, if you have a place to put them. We have a lot of clients who work with hosting providers who run things in their own data centers. Don't run into a lot of clients that have their own data centers anymore. So that is SQL Server on VMs on-prem. And I believe that's going to take us to how. So from my perspective, there are a couple of different kind of facets to how. Backup restore, log shipping is an option. And then there are migration tools that are provided by Azure and other cloud providers to allow you to migrate things up. And so I'll talk a little bit more detail here. So backup restore, you can use a traditional backup restore plan to pull a full backup of the database as you're migrating, restore that on the destination side in no recovery, and then at cutover time, potentially pull a diff or apply log backups to bring that destination up to speed at migration time. Log shipping is another option. You can use log shipping both with SQL Server on VMs in Azure, and you can also use it with managed instance. You can use managed instance as a log shipping destination. And this effectively just takes your log backups from your source system and copies them and then applies them on the destination system. And then at migration time, you can just break that chain or break that connection and then bring the source databases online. And then finally, as I said, there are migration tools available. There is a full suite called Azure Migrate, and that will sort of handle all of your migration. If you're migrating database instances along with application servers, Azure Migrate will take your source systems and figure out, you can figure out where you're going to put them on the destination side, and it will help you through that whole migration process. There are tools from Microsoft to figure out what your compatibility with your destination is going to be, and that is true for both version upgrade. So if you're moving, say, from SQL Server 2016 to SQL Server 2022, it will tell you what you need to change or potentially might have issues with in that version upgrade. And then it will also give you that information for the managed solutions I talked about, Azure SQL Database Managed Instance. So There's going to be a resources slide, and those resources will be emailed out after this, and there'll be some links to more information about those migration tools. So with that, I'm going to stop talking for a minute and turn this over to Jeff.
Thanks. So let's back up a little bit for a data lake. Make sure we're on the same page. What is a data lake? And the first bullet point is kind of a something that comes up pretty easily when you're going to look for this and search for it. It's really just a central repository where you store structured, semi-structured, and unstructured data, often considered part of a modern open scalable data architecture. And there's a lot of use cases. I just picked out a few here. Streaming things, make decisions on things as they occur, recommendation kinds of things. Retailer that is omni-channel. I want to bring together data from a lot of different connect points with my customers and make decisions based on that. Internet of Things. I've got hardware sensors, maybe in a home or car or factory or something, and I need to bring all that data together to better understand what's going on and make possibly real-time decisions. And then something I've had a little more experience with lately, science and data science using machine learning and modeling to predict customer behavior and market to your customers. Next slide, please. So I'm going to kind of merge the where and the how into step-by-step thing, because as I back up here, I was kind of thinking some of this is migrating and some of this is building out new. So I'm kind of taking the perspective of maybe I don't even have an environment there already, and what are the steps I need to do as I go through this. So I'm going to walk through these steps here. If you go to the next slide, please. Oh, there we go. So evaluate, choosing a vendor. This is a challenge. So, what you might make a simple statement and say, we've already got, Active Directory with Microsoft. We're already using SQL Server. We're already deep into Microsoft products. So maybe I should look at Microsoft Azure. That's fine. Who are your vendors now? What are you, who are you working with? I would say most of these have, pretty similar or expansive opportunities between the big three as far as what they can do and the tools they have to deal with the data. But you want to look at each one of these. What is the cost base? I went back to the cost estimator before. What's it going to cost? How am I going to integrate with that? Do I have any tools like ERP, or do I have anything in my environment that is going to tell me I really need to go with this vendor because this tool is critical to my business on a day-to-day basis, and it only works with this one, cloud provider? Or in some cases, you'll find, hey, maybe we release to all three of these cloud vendors, but we always release to Amazon first. I've seen that a couple times. That could be, maybe that's a reason you might want to consider Amazon, for example. And then also I like to think about, as you're evaluating the vendor, what are your in-house skills? Is there skills that you have that are going to transfer over to one of these more than the other? Maybe if you don't have skills in-house and you're going to have to upgrade, are there technical skills, whether it's consulting or full-time employees, people looking for work in your area? If you're going to, I would say of these three, Google GCP has probably the lesser of the adoption rate. If you were going to them and you were in a small town and you required people to come into the office, you might have a small pool of folks to work with. So as you think about this and you think about who are your alliances, maybe you're already working with some of these vendors or consulting companies, who are they working with and what would they recommend, so you have the support you need as you migrate into this. Next slide, please. So let's plan in a step out. And, I would say start with something small, whether it's a proof of concept kind of thing, an existing application that you can migrate without rewriting. Start with something simple, start working in the development environment. And as you go through this and you develop out the environments, you'll learn about performance. You'll learn about best practices. You'll learn about how to architect things in these environments. And along that way, you're going to have to define what's your development environments look like. What are my languages? I might have code repositories. Maybe previously I was in a database integrated with an ETL tool environment, and it kind of handled all that. Now I've got to worry about GitHub. I've got to worry about Terraform, building out, cloud infrastructure and things like that. These are all things that I need to piece together. So you need to think about those things. What are your target environments that you're working with? So there's a lot of pieces there that can take a lot of planning and architecting to make sure that it works out properly. And as I said near the end of here, think about who is in your area where you can get help to assist with that, maybe the vendor itself, other people in-house. And finally, do not skip over reference architecture and best practices. All the vendors have reference architecture. If you go into Amazon, AWS, they'll have reference architecture for certain things you're building out. Maybe I'm building a big data analytics solution. Maybe I'm building an online system that's going to have chatbots or something. It'll have reference architecture for that and tell you what tools they think you need for that. So as you plan this out, don't skip over those. They are great starting points. Many times in my work, when I've been questioned about going this way or that way, I would go back. If I'm not sure, let's go back and look at the reference architecture and see what that vendor said, because that's usually a good starting point. Next slide, please.
Sorry.
Oh,
Mouse wheel's not working.
So yeah, no worries. So this is a lot. This is messy. I chose Databricks here. One reason I've got some familiarity with it, but honestly, if you were to pick out AWS big data reference architecture or something like this for Azure or GCP, you're going to find at least as many components as this, and it's overwhelming. The first time I worked with AWS, it's overwhelming. It very much so. But as you look at this, they're like, okay, when I'm thinking data transformation, I've got sources on my left. I've got some transforming in the middle. Maybe I've got batch processes. Maybe I'm doing real time. Maybe I'm doing machine learning. Maybe, and I've got all these controls in the middle. Maybe I'm sharing with other environments. And then I've got to have some sort of place I'm delivering it to, whether it's downstream systems. Here, they've got Amazon QuickSight. You could have Power BI, other tools like that. So this is a little overwhelming. So that's where I'm saying go back and look at the reference architectures, work with the vendors, work with your in-house consulting folks to figure out where to start with here, because it's very easy to get overwhelmed. In this case, Databricks has the data intelligence platform. Basically, they put the things that are in kind of the green gray boxes here in their environment. So they've got Unity Catalog that sits over your data lake storage and makes it look like a database. And now I've got tables and schemas and I can run queries against it. So there's some things like that they make it a little bit easier. Is there a tool in the other environments where I can do it? Sure. AWS has Athena, but it doesn't necessarily have all this stuff integrated as easily. You may be able to do it without an environment like Databricks, but on the other hand, you may have to do more integration yourself. Yes, there's going to be a cost. They're going to have licensing costs associated with this if you were to go this route. But it does kind of integrate some things and make that a little bit easier for you from a management perspective. Next slide, please. So monitoring, I can't emphasize enough to set up billing alarms and cost tracking. I mean, it doesn't take long until you hear the story of someone that started up a cluster and forgot about it, and it ran for 3 days and they ran up a $5,000 bill or something like that. So how to avoid those things? The vendors have billing alarms and cost tracking, and you can limit people to a certain amount. So start with some limits there. So as you're experimenting, you don't have sticker shock, and then look at your bill as regularly as you can. It is really tricky. You want to try to tie that bill back to that estimator, but the bills are complex. I've seen the bills in Amazon AWS, and it can be hard. Oh, I've got this networking thing. I copied data out. I had a VPC set up so I could share information across regions. I had cross-region replication. I had to pay extra storage for that. So tying this all back is important as you monitor it and you know what's going on. Look for resource usage. And I can't tell you enough. If you had this environment on-prem and you think you need this certain size machine because that's what you had in your data center, and you build the same thing over the cloud, and you start looking at, hey, what do you know? I'm 20% used at peak over this period of time of these batch loads or even real-time feeds. I could probably get by with a smaller machine and save some money and not have wasted resources. So it's easy to do that, monitor it. The tools make it easy, and continue to go through this process as you do that. Set inactivity timeouts. A simple thing. I think Databricks default on a cluster is, at one time I was thinking, is hours. It might even be days or a day. It's crazy. Whereas most people set it to like 30 minutes. Set these things so you're not surprised later, and make sure you include other costs. If you were to use a tool like Databricks, you're going to have a licensing cost. If you're going to have Power BI, you're going to have to pay for that. One of the other ways to think about as you're monitoring things that you're building out in the cloud is running things in parallel. I worked with an environment where we migrated a data science application from an on-prem Hadoop environment over to Databricks in Azure Databricks in the cloud, and we would run things in parallel and write out to the same storage area, and then run validation things against them and say, okay, is it exact, or is it close, or is it good enough? And run those things in parallel for a while. So if you're migrating over and you've got, especially if you've got to rewrite code, be aware of this. You might want to run things in parallel for a period of time, make your users, business owners feel comfortable with it. And like I said, I kind of mentioned total cost of ownership. So I think we kind of stepped on that. Can you go to the next slide, please?
Yeah.
So takeaways. There's so many pieces here. It's hard to dig into all the details. So I'm going to try to pick off the nuggets that stick to me, as I've been through this before, that I think you need to be aware of. Is don't underestimate the migration from on-prem to cloud. I have been environments, and I have seen people that I work with these ETL tools and, PL SQL in a database, et cetera. And now, like I said, now I got to learn GitHub. Maybe I've got to learn CI/CD pipelines. I've got to learn deployments. I got to learn branching strategy. I've got to learn all these other things that I never had to worry about before. And that can be mind-blowing for people. You need somebody to go alongside of them, help them through that process. In my opinion, Python is not a complex language, and it is a widely used language. So it's a great place to start, especially in the data world. It's got super high adoption. If you go with some of these tools that take a SQL view of the data and data warehouse, you can do most everything with SQL. Maybe you have some Python wrappers, but you can move data with just SQL. Okay, now there's something that's very similar that people can use from old to new. Some technologies may not migrate. If you've got a heavy use of stored procedures, I know I've seen a pattern before where people would use SQL Server integration services to call stored procedures in a SQL Server database. Some environments aren't going to handle stored procedures. If you go to a database, great. But if you go to a data lake and you've got a layer sitting over it, they're going to probably expect you to use SQL, and they're probably not going to have stored procedure support. So now I've got to rip those pieces of code apart. I've got to put them in a Python script. I've got to put them in a Databricks notebook. I've got to do something with it to make those things run, because I can't put a store procedure in a database because the database doesn't exist. It's this different entity with storage underneath and a database type layer sitting over it. SQL tuning and Spark tuning, difficult. In my opinion, Spark tuning is an art. I can learn explain plans. I got pretty good at doing Exadata explain plans, and Spark tuning was kind of like starting over, understanding spill and understanding things like that you have to do. There's great resources online. Leverage those, go to conferences, bring in people you can as you understand that, because I could take something that runs now and move it over there and have a Spark error, and all of a sudden, I get just enough data and it just doesn't give me an answer. It goes from, being done in 5 minutes to not being done in an hour. So get educated on those things. As I mentioned before, best practice, architectures. I do mention here medallion architecture. That's getting pretty widespread adoption across the platforms. That's basically saying, when I bring in data, I've got my bronze layer, which is raw, and I'm not doing anything with the data. I'm just taking it from my source and putting it there so I have it, and I don't have to go to the source data. Silver is doing simple transformation, simple data cleansing, not aggregation. And then gold would be doing some kind of aggregation and preparing that data for reporting or analytics. So that's getting to be a pretty widespread architecture, and you'll see a lot of vendors refer to it. If you can, consider Delta Lake or Apache Iceberg. Both of these um, are architectures that sit over data lakes and allow you to do SQL, allow you to do ACID transactions, allow you to do insert, update, deletes, allow you to do schema evolution, allow you to add columns and things like that to files under the covers. Delta Lake is a little more standard in that, the Parquet files have got a pretty wide adoption in data lake cloud environments. Apache Iceberg is kind of more geared towards super large data volumes and data science and data analytics. And then monitor the cloud costs, like I said, and review enhance. As I threw this bullet point in the end, I thought, gosh, I can't be skipping governance and security. One of the nice things that Databricks does is it handles a lot of that for you through Unity Catalog, but you can't forget it. Obviously, if you're in a financial state or any state where you got PII data or whatever, you've got to be aware of that, and you really need to, putting this at the end doesn't do it justice. I should have put it back in the beginning and plan. So those are some key points that I had as you kind of think through the planning and where to get help, because that diagram is overwhelming and can be overwhelming. And hopefully this will hit you some key points and get you started in the right path. I think that's all I had for that, Frank.
Yeah. So just to follow up on what Jeff said, the monitoring is really important, and making sure that you know what gets stood up and don't let things run. Had a client who they wanted to test out availability groups. So they built out a 2-node availability group with machines with some serious horsepower, and it ran for, I think, 3 months, and they weren't using it. And the bill was in the 6 figures. So it can add up really quickly. The other thing from that planning perspective, you should be aware of how easy it is to move out of the environment you're moving to. The reason I say that is that with Azure SQL Database, it does take backups for you. It runs your database backups, but you do not have access to those backups. Basically, if you want to restore an Azure SQL database, you either do it through PowerShell or you do it through the Azure portal, and you give it a point in time and it will do that restore. But those underlying backup files are not available to you. So if you want to move out of Azure SQL Database, you have to pull what's called a backpack file, which effectively scripts out the schema for your data, and it also scripts out all of the data in your tables. And if they are large tables, that can be painful. And I've been through that, actually moving from Azure SQL Database to GCP. So just keeping that in mind can be really helpful. So next question we got is that when? And this kind of gets into that idea of documenting a plan, determining the timing of your test environments, getting that application owner approval into that plan. And then if you do have that option to run in parallel between new and old, as Jeff was talking about, being able to, see what things look like in the old environment, running in parallel in that new environment, and doing that comparison and making sure that everything looks the same. And if it doesn't look the same, figuring out how dissimilar can it be? How much of a variance can you have there? Does everything have to look exactly the same, or is there some wiggle room there? That takes us to the end. That was sudden. So I mentioned the resources slide. Jeff's got a couple of bullet points here with information about Databricks and AWS. I've got a link to the Azure SQL Database high availability slides that I talked about, and it'll give you more detail there. And then we both got links to the estimators for AWS and Azure. And then I'm going to be adding a couple of additional slides in here, or a couple of additional links in here for some more specific information about the migration tools that I talked about. So with that, Andrea, do we have any questions?
Doesn't appear to be any questions just yet. So we will definitely get this video sent out to everybody in the audience today. And then Frank, if you want to just pop to the next slide while we see if anyone else has any questions that come in. We're excited to announce April's series, so keep your eye out for an invite to this, but we will be talking about security first database management, what every business must know. So should be a pretty exciting and relevant topic with everything that's out and about there now. Doesn't look like we have any additional questions. So Frank and Jeff, I don't know if you have any closing remarks.
No, I would just say when you send out you're going to send a link to the video out to the attendees.
Yes, it'll automatically go out to them.
Ah, I was just wondering if you wanted to drop my email in the chat and Jeff's email in the chat, just in case people have questions after the fact.
We'll absolutely do that. So
Yeah, absolutely. Reach out if you have questions. Definitely.
Yes.
Lots of information.
I like to joke that I like to talk about this stuff and my wife doesn't. So any and all questions are welcome.
Agreed. Yep. All right. Well, we really appreciate everybody attending today, and we're enjoying this series. We hope you are too. I'm dropping Jeff's address in there now, and Frank's is already in there. So feel free to reach out to them individually, or you can always hit us up at info@fortifieddata.com. So hope everyone has a wonderful afternoon. Hoping it's spring-like weather everywhere. So have a good one.
Yeah.
All right. Thanks, everybody.
Thanks.
Bye.